Find the derivative of the following two functions. Let's look at number one here. Y is equal to e raised to power 10 theta. So just looking at this problem, we can see like we are familiar with a natural logarithmic function e to the x, right? Derivative of e to the x is e to x. It stays the same. So, and from that we can already tell that chain rule applies here. And let's apply what we have learned so far. And let's say outer function is what? E to the x. And we have the inner function g of x where x is equal to tan theta. And let's take the derivative of this. Outer function stays the same, e to the x. And now let's take the derivative of the inner function. And we know that tan theta is derivative of tan theta is secant square theta. Okay, so the derivative of this function dy over dx is what we have learned. Derivative of outer function with respect to g of x multiplied by derivative of gx, inner function derivative. Okay, so we have e to the x with respect to g of x, which is tan theta, times derivative of gx is secant square theta. And this is your answer for this one. Let's look at number 2 here. E raised to power at times sine v theta. Vt, sorry, not theta. Okay, just looking at this is now two functions. You, even if you apply the same chain rule here, you can take, okay, there are two functions. How are you gonna try to differentiate with inner and outer functions as the values are changing? This is a times, this is b times t. So just looking at this, you can tell that the product rule applies here first. Okay, product rule first and then chain rule. So make sure you're paying attention to what's in the problem and then apply the rule based off that, not just simply go blindly with chain rule and then mess up your points on quizzes or exams. Already. So derivative of this function with respect to t is what? Apply the product rule first, so which is a times, which is e raised to power at times derivative of v, sine of vt plus b times, which is sine vt derivative of a, e to the at. Alrighty, so now if you have already figured this out, we know that derivative of sine t is cos t, but now a constant is associated to this t, right? So we can tell that chain rule applies here. Uh, Outer versus the inner function. You can simply write this down, or as of now, you already know the patterns, right? So sine t, derivative of sine bt is cosine bt only when we take the derivative of bt, the inner function itself, which is times b. Same thing here, plus sine bt. Chain rule applies here because e to the x is, yeah, e to the x derivative. But now constant is associated to this. So this is again e at, but take the derivative of this inner function of t, then this is a. So we have at b of cosine bt plus EAT A of sine. You can write in either way. And let's find the common terms here. E Raised to power 80 is common here, so we can take b cos bt as here sin bt. And here is your answer. I hope this helps. Thanks for watching.